are the centerpiece of modern armies. This video ordnance program will examine the impressive new battle tanks used to defend NATO's Central Front. If you travel along the German Autobahn in the autumn months, among the normal traffic along the route, you are likely to encounter hulking green battle tanks. With the harvest in, the tanks begin emerging from their lairs in the forest for their seasonal war games along the inter-German frontier. NATO wages its war games through the winter months. The Blue Army and the Orange Army engage in mock combat, practicing for a war they hope will never come. Northern Germany is the home for the British Army of the Rhine. The mailed fist of the British forces is their impressive pair of battle tanks, the Chieftain and the Challenger. Britain was the pioneer of tanks. The British Army introduced tanks to the battlefield in 1916 and have played an important role in their development ever since. The Chieftain is the older of the current pair of tanks and was introduced into service in 1966. At the time of its initial deployment, the Chieftain was the most heavily armed and most heavily armored of all NATO main battle tanks. Most NATO tanks of the 1960s and 70s were armed with a British-designed 105mm gun. In contrast, the Chieftain was armed with a more potent 120mm gun. The Chieftain's design placed great stress on armored protection. The tank's turret was carefully contoured to take best advantage of its thick steel armor. In the 1970s, a team of engineers at a British Army research centre near Chobham, England, developed a radical new type of tank armor. The new armor was codenamed Burlington, but it has become better known as Chobham armor, after the location of the research establishment which developed it. The new Challenger is the first British tank to incorporate this highly effective protection. The exact configuration of this armor remains a closely guarded secret, but it is believed to consist of complex layers of metal and advanced ceramics. It makes tanks nearly invulnerable to frontal attack from deadly anti-tank guided missiles. Besides this enhanced protection, the Challenger is considerably more mobile than its predecessor, the Chieftain. It is powered by a 1,200 horsepower Perkins Condor diesel engine, which gives it speeds of up to 35 miles per hour. The advanced hydro-pneumatic suspension gives the tank a smooth ride even over obstructions and rough terrain. One of the most important advances in tank design over the past decade has been in gunfire controls, which permit the tank to fire on the move. The heavily armored turret weighs 20 tons, yet it must be moved with extreme precision to hit targets a mile or more away. These tests on a turntable provide the clearest example of this critical feature. A more advanced version of the Challenger 2, is currently under development with even more sophisticated fire controls. The Challenger is supported by an armored repair and recovery version. This version is capable of recovering a bogged down or battle-damaged tank, and its hydraulic crane can be used when carrying out engine repairs. Britain has always played a prominent role in supplying tanks to armies overseas. There are often restrictions on the export of the latest tank design due to highly secret technologies involved. Also, many armies in the developing world cannot afford the highly complex and expensive tanks adopted by NATO and desire a less elaborate tank. So besides manufacturing the Challenger for the British Army, Vickers Defence Systems has also designed tanks specifically for export. The Vickers Mark 7 is an interesting example of British-German industrial cooperation, with a Vickers-designed turret and Leopard 2 hull supplied from Germany. The Vickers Mark 7 has advanced solid-state fire controls capable of hitting moving targets at long ranges. The Vickers Mark III is the latest evolution of the Vickers main battle tank. Earlier versions serve in the armies of India, Kuwait, Kenya, and Nigeria. Some armies desire a lighter and more mobile tank with less armor protection but a high level of firepower. This has led to an interesting British-American venture, the VFM-5 light tank, with a Vickers turret and an FMC hull. Although under 30 tons, it is armed with a 105mm gun. Britain's strong traditions in tank design have provided NATO with critical technological breakthroughs, like Chobham armor, a tradition likely to endure. Across the hot, dusty prairies of Texas, sleek tanks hunt out their quarry. Tankers of the United States Army's 1st Cavalry Division wage mock combat using one of NATO's newest and finest tanks, the M1 Abrams. The Abrams is named after General Creighton Abrams. Although Abrams is best known as the commander of the United States Army forces during the Vietnam War, he is a legendary figure amongst the American tankers for his hard-charging leadership of the 37th Tank Battalion in World War II. American tanks have changed greatly since Creighton Abrams' days. The M4 Sherman tank, like the one commanded by Abrams in World War II, was armed with a 75mm gun. Today's M1A1 is armed with a 120mm gun that is 3 times as powerful. The Sherman was protected by a bit more than 2 inches of steel armor. The advanced Chobham armor of the M1A1 offers protection 12 times as great. The M4 was a fast tank for its day, capable of 25 miles per hour on roads. The M1 Abrams is nearly twice as fast, even in rough terrain.
The increased speed causes you to be able to do a lot more things than you normally could with the slower M60 series. And plus, it opens up some terrain to you that you can use as high-speed avenues of approach, which you didn't have before.
Development of the M1 began in the early 1970s to replace the older M60 series of tanks. The lessons of the 1973 Mideast War suggested that more attention had to be paid to the threat of guided anti-tank missiles. The Abrams design placed protection as a major priority.
It should be mentioned that from the outset of the design program for the M1, the user, the soldier, was at the center of our thoughts. That was manifested not only in trying to make crew survivability the key new characteristic of the tank, but also to make the tank fightable.
Chobham armor provided a major advance in defeating the missile threat and gives the Abrams its distinctively slab-sided appearance. The greatest risk to the crew was the ammunition carried in the tank. On the Abrams, the ammunition was positioned in a special compartment at the rear of the turret. It was separated from the crew compartment by special blast doors. If the ammunition is ignited by an enemy projectile, the explosion is vented upwards, away from the crew, through special blowout panels. This once secret test footage is a remarkable demonstration of this feature. In spite of the conflagration in the rear of the turret, the blast doors protect the crew from the fire. Another key aspect of the M1's design was its weapon system. The main gun itself is only one element of the overall weapon system. Tanks appear to be crude cast-iron monsters, but their insides are crammed with high-tech, solid-state electronics designed to operate in the gritty environment of the modern battlefield. Previous generations of tanks had to stop to fire. The M1 and other modern NATO tanks can fire on the move. The turret stabilization system keeps the gun aimed at the same point, no matter how much the tank is jostled around by the rough terrain.
The M1 is really effective with the stabilization system, which is built in, whereas on the old tanks, it took a lot of short halts where you stop, move, and stop, move. Of course, with the M1, you can continue to ride anywhere from 30 to 35 miles per hour and fire and get a first round hit.
The initial version of the Abrams, the M1, is armed with a 105mm gun. The newer M1A1 version has a more potent 120mm gun. The Abrams Advanced Electronic Gunfire Control System gives it incredible accuracy at ranges over 1 mile. A muzzle reference system measures barrel warp caused by the heat of repeated firings. A wind sensor checks for crosswinds that would cause a projectile to go astray. A laser rangefinder accurately measures the distance to the target to within inches to ensure precise aiming.
We have a laser rangefinder system that allows us to be able to send out a laser beam that goes out and hits a target, bounces back, and determines the range based on the time of travel for the laser.
The data from the tank's advanced sensors are rapidly absorbed by a ballistic computer with little attention from the gunner. The Canadian Army Trophy Shoot is held every 2 years to test the abilities of NATO tank crewmen. In 1987, the M1 demonstrated the effectiveness of its advanced fire control system by beating all previous records for rapidly engaging and destroying its targets.
The speeds of kills on a modern battlefield are going to be totally different than they used to be, where you would shoot multiple times and not get hits. And nowadays, you have over a 90% probability of hit even while moving.
The advanced electronics are easier to use than the mechanical systems used in previous generations of tanks. Tank crews are now expected to hit their targets much more quickly and with greater accuracy than in the older generations of tanks.
The target will come up and stay exposed, depending what type of engagement it is, anywhere from 40 to 50 seconds. And then they will be expected to kill it within 12 seconds, okay, from the time that they actually initiate the engagement to the time that they kill the target. And within that, you have about 5 seconds reload time for the crew in case they have to fire a second round. But normally we get them on the first round.
The new NATO tanks also have an advanced sighting system fitted with a thermal imager. The thermal imager senses the minute temperature differences between man-made objects, like tanks, and the natural background. This enables them to locate and identify enemy tanks at night or in the daytime when they're hidden by smoke or camouflage.
Very improved system where it allows us to have basically daylight 24 hours a day. And we have eyes at night now that can see without the use of any other devices, i.e. IR searchlights, items like that.
Since World War II, tank crews have dropped in size from 5 men to 4.
The M1 is equipped with a 4-man crew. We have a driver. His basic job is to seek positions. That's in the process of handling the driving portion. And we have the gunner. He's to identify and acquire targets and fire them as well. And we have the loader. He basically take care of the area watch and also the rear section of the tank. And myself, I'm the tank commander. I pretty much keep control and overwatch over each other position.
Driving the M1 tank is not much different from driving an automobile, but it uses a T-bar steering yoke that is similar to a motorcycle's handlebar.
It has a different type of steering device. It's got a T-bar, and if you want to go left, you push to the right and pull to the left, and the track it holds the left track, and the right track continues to turn, and you'll go left, or opposite, you go right.
As in the case of Britain, American companies have developed light tanks suitable for export. One of the more successful has been the Cadillac Gauge Stingray. The Stingray is armed with a 105mm gun, but it is more lightly armored than the Abrams. The first army to adopt the Stingray was Thailand. France has long been one of the pioneers in tank design. The Renault FT-17 tank was the first true modern tank, with its main weapon located in a fully traversable turret. French tank designers are continuing this tradition with the development of the new AMX Leclerc tank. The AMX Leclerc is named in honor of Marshal Philippe Leclerc, who led the 2nd Armored Division in the liberation of Paris in 1944. The AMX Leclerc is in final development and will enter service in the early 1990s. As modern main battle tanks increase in complexity, their design becomes more protracted and expensive. In the early stages of design, a variety of concepts is studied. The AMX Leclerc designers investigated a number of novel turret and gun configurations. They settled on a conventional turret, but with many advances in gunfire control systems. We spoke to one of its chief engineers to learn more about the features it will include.
La puissance de feu d'un matériel dépend bien entendu de son armement principal.
The firepower of a vehicle depends, of course, on its main armament and on the fire controls which direct the main armament. In the case of the Leclerc, we have adopted a high-performance automatic fire control system integrated with an electric turret drive which gives the vehicle a high degree of accuracy, which is quite remarkable.
Si bien que la fonction de tir en marche sur la MX Leclerc devient véritablement.
In the case of firing while moving, it's a straightforward matter with the AMX Leclerc, which was not the case on tanks a decade ago. On tanks of the preceding generation, firing on the move required careful attention, and the performance was poorer than one found in the case of firing from the halt.
Aux performances que l'on trouve pour un tir à l'arrêt.
Battle tanks are becoming increasingly computerized to assist their crews in combat. The AMX Leclerc is the first tank to be built around a centralized digital electronics architecture. Tank crews no longer will communicate only by voice over radio, but will exchange critical information through the data systems.
L'AMX Leclerc, par son architecture numérique, les moyens dont il dispose, est en liaison.
The AMX Leclerc, with its digital electronics architecture, is in constant communication with the other armored vehicles moving along with it, whether battle tanks or command armored vehicles. There is data and information centralization aboard each vehicle.
Repose sur l'utilisation d'un bus qui parcourt l'ensemble du char.
Because of the centralized data bus functioning inside, the digital computer architecture centralizes and disseminates the data around the vehicle. This data is coded and can be used by other vehicles. So at any moment, in any location, you know with considerable precision where the vehicle is located, how much fuel it has, how many rounds of ammunition, and so on. The availability of this data permits operations in real time and the best possible employment of the full capacity of the tank in its tactics when equipped like this.
There have been so many advances in tank armor over the past decade that armor packages become outdated, sometimes in less than 5 years. The AMX Leclerc circumvents this problem by using modular armor packages which can be replaced by updated packages when new technology arrives. One of the key differences between the Leclerc and the current NATO tanks is the introduction of an automatic loading system to replace the human loader. With the conceptual design completed, the fabrication of testbed vehicles begins. These are automotive testbed vehicles used to examine the engine and suspension of the vehicle. The turret is not fitted, and instead, special instrumentation is used in its place to monitor the performance of the vehicle. turret subsystems are examined separately. Finally, a testbed demonstrator is assembled to examine the interaction of all the components. Once problems are resolved, the production vehicle begins to take shape. The AMX Leclerc contains so many secret features that this video of it has certain details electronically obscured. The French army is confident that its new main battle tank will enhance France's reputation for innovation in tank design.
The tank is one of the essential links in our policies. The Leclerc tank in 1991 will be able to penetrate every other existing tank on the battlefield, but also be able to respond to future threats coming from the enemy.
The still of an early December morning along the inter-German border is disturbed by the growl of tank diesels. A German panzer battalion churns the fresh snow in a sleepy pine forest. From the woods appears a platoon of one of NATO's most modern battle tanks, the vaunted Leopard 2. With the harvest gathered and the fields bare, the modern German army, the Bundeswehr, exercises its armored shield. Tanks were the spearhead of the German blitzkrieg in World War II. The legendary Tiger and Panther were among the most powerful tanks to roam the European battlefields during the final years of the war. Today they stand as silent reminders of the great armored clashes like Kursk, Normandy, and the Battle of the Bulge. Their place has been taken in the modern Bundeswehr by tanks of the Leopard family, the Leopard 1 and the Leopard 2. The Leopard 1 was the first German tank built after the Second World War. It entered service with the Bundeswehr in 1965. Compared to its wartime antecedents, even the monstrous Royal Tiger, it is much better armed. The Leopard 1's main weapon is the standard NATO rifled 105mm gun. It is capable of hitting enemy tanks at ranges of over 1.5 miles. The Leopard 1 is considerably more mobile than the tanks of World War II, with road speeds up to 35 miles per hour. This highly regarded design is the most widely distributed tank type in NATO service, with over 4,000 produced. The Leopard 1 also forms the basis for the Gepard, an anti-aircraft vehicle armed with a radar-directed twin 35mm cannon system. In the 1970s, the German army began development of a new generation tank called the Leopard 2. Though sharing a common name with its predecessor, the Leopard 2 is in fact a whole new design. Like the M1 Abrams and the Challenger, the Leopard 2 is protected by a thick hide of advanced armor. Its frontal area is nearly impervious to the deadly threat of anti-tank guided missiles. A 120mm smoothbore gun forms the sharp teeth of the Leopard 2. This gun spits out a 20-pound metal dart projectile at speeds of over 1 mile a second. This same gun was later adopted on the American M1A1 Abrams tank. Precision is ensured by a laser rangefinder. To keep the gun pointed accurately during high-speed travel, it is stabilized by a high-performance system. The effectiveness of this sophisticated network of gun and sensors has been demonstrated time and time again by success at the Canadian Army Trophy Shoot. This competition pits NATO's best tank crews against a challenging array of targets. Dutch and German Leopard 2 units have often emerged on top. The Leopard 2's rough exterior appearance belies its internal complexity. The turret is manned by 3 crewmen. The loader is responsible for handling the tank's ammunition. The gunner aims the 120mm gun and operates the sophisticated computer-aided fire controls. The commander acquires targets and directs the rest of the crew in their duties. In spite of the technical improvements of modern tanks, the life of a tank crewman is arduous. There is ammunition to be loaded, and there are a host of other chores to keep a sophisticated machine like the Leopard 2 in good operating condition. Tanks are expensive to operate in peacetime. A tank will wear out a set of tracks every 2,000 miles, and they cost over $50,000 for a new set. Electronic simulators can help reduce the cost of training of tank crews by as much as 60%. The Leopard series uses a simulator to train new drivers. Driving a 65-ton tank at 40 miles per hour requires special skills. The simulator is linked to a scale terrain model, and the computer provides the trainee with a realistic image of the countryside. Future systems will use computer-generated images. Once the driver completes basic training on the simulator, he transfers to special training tanks for hands-on experience. Special training tanks reduce the wear and tear on actual combat tanks and are less expensive to operate. The new generation of NATO battle tanks is the fastest on record. High combat speeds make the vehicles difficult to hit during fighting. The Leopard 2's 1,500 horsepower diesel engine gives the Leopard 2 very high cross-country speeds, up to 45 miles per hour. Its torsion bar suspension dampens the jostling of rough terrain. Modern tanks are too heavy to be made amphibious, so rivers are a major obstruction to tank movement. To circumvent this problem, the Leopard tanks are designed to snorkel underwater. The crew seals the vehicle, then employs a special tube device to provide air to the engine and crew. The NATO battle tank is an awesome combination of firepower, armored protection, and cross-country mobility. The tank remains the central element in all armies, but nowhere more so than on the plains of Central Europe. These weapons form an important part of NATO's deterrent strategy, crucial to maintaining a tense but lasting peace in Europe.